morning students. Today we are going to discuss about the topic synchronous program order on an asynchronous system in the course CS 8603 Distributed Systems. The learning objectives of this presentation are: we are going to learn about the concepts behind synchronous program order on an asynchronous system, and we are going to implement binary Rendezvous algorithm. So first we have to know what is deterministic program and what is non-deterministic program. So as I told, because of the partial ordering of messages, we have to make a repeated runs of the same program. Even in the repeated runs of the same program, we will get the same partial order. Thus, we can preserve the deterministic nature. But in some situation, we cannot expect such type of deterministic nature. For example, a receive call can receive a message from any center if the center is not specified. So it is non-deterministic in nature. If I send message to J and J send message to I concurrently using the blockic synchronous call, automatically it results in a deadlock. So it is again non-deterministic. So a program can behave as a non-deterministic program in distributed system. So we need a Rendezvous algorithm. So Rendezvous systems are a form of synchronous communication among an arbitrary number of asynchronous processes. That is, we have arbitrary number of asynchronous processes, but anyway we are going to implement a synchronous communication. So that's why the topic name is synchronous program order on an asynchronous system. So all the processes involved are meet with each other. So each and one meet with each other. So which means that each and every process communicate synchronously with each other one at a time. So we have two Rendezvous algorithm. One is binary Rendezvous algorithm and the other one is multi-way Rendezvous algorithm. So what do you mean by binary Rendezvous algorithm? Means here we concentrate on only two processes. So when two processes agree to synchronize, it's known as binary Rendezvous algorithm. But what is multi-way Rendezvous algorithm means? When more than two processes agree to synchronize, it is called as multi-way Rendezvous algorithm. So anyway, we are going to know about binary Rendezvous algorithm. We are concentrating on binary Rendezvous algorithm. So if multiple interactions are enabled, then the process can choose any one of them and it tries to synchronize with the partner process. So for synchronization, we can go with the following scheduling types. Either we can go with schedule online, atomic and in a distributed manner, or you can go with schedule in a deadlock free manner, that is a crown free, or you can schedule to satisfy the progress property in addition to the safety property. So one of the binary Rendezvous algorithm is Bergodia algorithm. So what are the assumptions we have made means the receive commands are always enabled from all the processes. Once a send command is enabled, we cannot disable them in the middle. And to prevent a deadlock, we use a process identifiers. And each process schedules only one send event at a time. So in this Bergodia algorithms, we have three types of messages: acknowledgement M, request of M, and permission of M. So now we are going to see the steps in Bergodia algorithm. So assume Pi is the highest priority process and Pj is the lowest priority process. So Pi sends a message to lower priority process. So how can we perform this? So if Pi wants to execute a send of M to the lower priority process Pj, then after executing send of M, this Pi should block. So how much time it needs to block? Until it receives the acknowledgement message from the other process. Okay. So in that, send event gets completed. In the meanwhile, if we receive any message from a higher priority process, or request of M for synchronization, then all the types of messages, that is all these messages are queued. Okay, so this is the diagram which shows. So Pi is higher priority process and Pj is lower priority process. So when Pi executes send of M to Pj, Pi should be blocked. How much time it has to block? Until we get an acknowledgement from Pj. Okay. So that's about first step. In the second step, if Pi wants to execute send of M to a higher priority process Pj. Now Pi is lowest priority and Pj is highest priority. Okay. So Pi seeks permission because Pj is higher priority process. So Pi seeks permission. So while Pi is waiting for permission, it won't get blocked because Pi is a lower priority process. Always the lower priority process is not at all blocked. Only the higher priority process is blocked. Okay, so that's why Pi remains unblocked. So at that time, it can receive a message from any process. So for example, if it receives a message M from a higher priority process Pk, so what it needs to do means Pi accepts the message immediately and it immediately executes the receive of M and then executes sending of acknowledgement of M to the process Pk. Okay, this is one case. Similarly, if the request message arrives from the lower priority process Pk, then Pi executes permission to Pk. After that, it gets blocked. Okay. So because Pi is a higher priority process, Pk is lower priority process. So Pi is blocked. It is waiting for the message M. When the message M arrives, then immediately it executes the receive of M. Okay. So when the permission of M arrives, Pi knows the partner Pj is synchronized and it executes send of M. Only when sender and receiver handshake with each other, then the communication takes place. So the third case is request of M arrived at Pi from a higher priority process Pj. Okay. And the fourth case is message M arrived at Pi from a higher priority process Pj. Then processing of message when Pi is unblocked. So these are the several cases for Bargodia algorithm. So with this we have concluded Bargodia algorithm. Thank you.